Sampling and sampling distributions. First, let us define what is a parameter. A parameter is a numerical value calculated by using all the data in a population. So since we're talking about a population, whatever numerical value that we can get from the data of that population is what we call a parameter. Let us consider this given data. So our parameter here, or our population, is a family member that consists of 5 members with a corresponding length in time in minutes. Now, let us compute the mean of the length in time of the 5 family members. So we have the mu is equal to the summation of x over n. So we will now get the summation of all the data in the given populations. So we have 15 plus 20 plus 30 plus 5 plus 10 all over 5. If we simplify this, the result is 80 over 5. And we can still simplify this. The result is 16. Now, since we already have the mean, let us now compute the variance of the given population. To compute the variance of the population, we will use this formula. So, let us now simplify, or let us now substitute the values of x and mu to the given formula, since we need to get all the summations of the 5 members. So we have 15 minus 16 squared plus 20 minus 16 squared plus 30 minus 16 squared plus 5 minus 16 squared plus 10 minus 16 squared all over 5. Then, if we simplify this, the result, we have negative 1 squared plus 4 squared plus 14 squared plus negative 11 squared plus negative 6 squared all over 5. Then, simplify this, the result is 370 over 5. And we can still simplify this, the result is 74. And this is the variance of the given data in the population. Now, the standard deviation, we can only get this if we get the square root of the variance. Since the variance is 74, the square root of 74 is 8.60. And now, you have observed that we already have the numerical value of 16 for our mean. And this is what we called the population mean. We also have a numerical value of 74, which is our variance. And this is what we call the population variance. We have 8.60 for standard deviation, and this is what we call the population standard deviation. And these numerical values are what we call a parameter. And take note, if we're going to compute the mean of a population, we will use the symbol of mu to indicate that is the mean of a population. And we will use the symbol for the variance, the square of sigma or sigma squared, to indicate that is a population variance. And for the standard deviation, we will use the Greek sigma to indicate that is a population standard deviation. So, again, the parameter is a numerical value coming from the populations, or calculated from a population. Now, how about if we only get samples from a population? Ano naman ang tawag sa numerical value that we calculated from the samples of the population? But before that, let us discuss or recall first a random sample. A random sample is a set of data taken from the population in such a way that every set has the same chance of being selected. A statistic is a numerical value calculated by using only the data from a sample. So kung kanina, if the numerical value calculated using the population is what we call the parameter, if it is from the samples, it means that it is what we call statistic. Now, let us consider the same set of data. So we have a family member that consists of 5 members. Now, but our concern, how about if we only pick 2 samples from this given data or from the 5 members? So for example, we have Vilma and Sarah. So you have observed our the size of our the random sample size is n is equal to 2. So we only get 2 out of 5 members. Now, if we compute the mean of this, okay, take note if we're going to compute the sample mean, the symbol of a sample mean is x bar. So kung kanina, sa population mean, we use the mu. Then, for a sample mean, we use the x bar. And that is equal to the summation of x over the, sample size n. So since dalawa lang yung kinuha natin, our n here is 2. So let us now solve the sample mean. We have 15 for Vilma and 20 for Sarah. If we're going to add this and divide by 2, so we have 17.5. Okay, so this is now what we call the sample mean. How about the variance? Okay, we will use this formula. So what is the difference? Of course, we use the symbol S squared to indicate the sample variance. Okay, kanina sa population variance natin, we use the sigma, the Greek letter sigma. But here we use the small letter in our English alphabet, S to indicate the variance, S squared to indicate variance. And the difference is that the denominator, if we're going to compute the variance, for a sample, we need to subtract the sample size to 1. So we have n minus 1. So let us now substitute or compute the variance. So since there are only 2 samples, so we will now use this 15 minus 17.5 squared plus 20 minus 17.5 squared all over 2 minus 1. Then simplify, we obtained negative 2.5 squared plus 2.5 squared all over 1. So if we're going to simplify this, the result is 6.25 plus 6.25. So the result is 12.5. And this is now our sample variance. And to get the sample standard deviation, so the symbol for a standard deviation, if we're going to calculate using the sample, is S. So get the square root of the sample variance, which is S squared. So the result, since the sample variance is 12.5, get a square root of 12.5, the result is 3.54. Now, since we already have 17.5 as a numerical value calculated from the sample, 12.5 and 3.54, so this is what we call the statistic. So the statistics are, we have the sample mean, the sample variance, and the sample standard deviation. Now, let us use the same set of data from our previous examples. Okay, so we already discussed the parameter and statistics, their differences. When we talk about parameter, it means that it's a numerical value calculated using the data, all the data in the given population. While statistic, again, that is a numerical value calculated using only samples from a population. So that's the difference between the two. Now, let us now create a problem using this given data. Nicolaya is interested on how long it takes the 5 members of her family to finish their dinner. The length in times, which is in minutes, are shown below. Construct sampling distributions for the sample means and for the sample variances and sample standard deviation using a random variable of size n is equal to 2. Now, before we're going to compute the sample means and sample variances and sample standard deviations of the given random variable of size n equals to 2, we need to find the possible combinations. Okay, from the given 5 members, so we only need to pick, okay, 2 samples. So let us now find, okay, how many possible combinations that we can create from the 5 members. So with the size of 2. So let us still start with Vilma, Sarah. So the data, we have 15 and 20. We have also Vilma, Louis, 15, 30. We have also Vilma, James, so 15, 5. We have also Vilma and Leah, we have 15, 10. We have Sarah, Louis, 20, 30. We have Sarah, James, 20, 5. We have also Sarah, Leah, 20, 10. Can we write Sarah, Vilma as our possible combination? Okay, at this time, since Vilma and Sarah already appeared, so we will not write Sarah, Vilma, because they are just the same. So exactly the same set of combination. So we will now proceed to Louis, James. We have 30 and 5. We have Louis and Leah, 30, 10. And we have James, Leah, 5, 10. So these are the possible combinations. So there are 10 possible combinations that we can create. So let us now put it in a table. So this is what we call the sample values. So we have now 10 sample values. Let's the sample mean. So again, we will use the X bar. So we will use this formula. So in the first sample values, so with the given set of, with the given data 15 and 20, so to find the sample mean, so we will now get the summation 15 plus 20. since there are only 2 data per sample from the given set of sample values. So 15 plus 20 divided by 2. So that is 35 over 2, or that is 17.5. So the sample mean of the first set of sample values, we have 17.5. Second, we have summation of x over 2, which is 15. So this is our second, 15 and 30. So we have 15 plus 30 over 2, or that is equal to 45 over 2, and the result is 22.5. And that is the sample mean of the second set of sample values. Now, you try to compute the third set to the last set to find the sample mean of the given sample values. So just pause this video, then try to solve from third to the last. Okay, let us now reveal the sample mean of the third and the last. So we have 10 for the third sample values. Fourth, we have 12.5. Fifth, we have 25. Sixth, we have 12.5. Seventh, we have 15. Eighth, we have 17.5. And ninth, we have 20. And last, we have 7.5. So these are the sample means of the given sample values. Since the statistics, which are the sample means, x bar, estimate the parameter, which is the population mean, mu, it is expected that the mean of our sample means is equal to our population mean. If you also recall, class, to the given population, which is a family that consists of 5 members, we already computed the population mean, which is 16. So 16 minutes. Now, let us now use the given statistics or the sample means. Let us now try to find, the summation of all this mean and to compare the mean of the population. So we have the mean is equal to the summation of all the sample mean over 10. There are 10 sample values. So just add all the sample means, then divided by 10. So you have observed that the result is also 16. So it is true that the mean of our sample means is equal to our population mean. Now, let us now create the probability distribution of our sample mean. So, let us start with the first sample mean, which is 17.5. So, you have observed that in the given sample mean, there are two 17.5, 17.5, and 17.5. First sample values are first set, and the 8th set. So they are just the same as sample mean, which is 17.5. So the probability is that there are 2 out of 10, and that is equal to 0.20 or 20%. Next, 22.5. So there is only one, sample mean of 22.5. Therefore, we have 1 out of 10 or 0.10 or 10%. 10, there's only one. So 1 out of 10 or 0.10 or 10%. 12.5. So you have observed that there are 2 sample mean of 12.5. The 4th and the 6th. So therefore, we have 2 out of 10 or 0.20 or 20%. Next, 25, there is only one. So 1 out of 10 or that is 0.10. Next, we have 15. There's only 1. So 1 out of 10 or 0.10. Next, we have 20. So there is only 1 out of 10. So 0.10 or 10%. Then 7.5, there's only 1 out of 10. So 0.10. Always remember, class, that the probability or the sum of all the probability in the given set of the total probability must be equal to 1. So it must be equal to 1. Now, let us now compute the variance of the sample mean. To compute the variance, we will use the formula s squared is equal to the summation of x minus x bar squared all over n minus 1. So at this time, we have only 2 data per sample values, or we have only 2 values. With the sample, let us start with the first set. So since the sample mean is 17, so we have here, we have 15 minus 17.5, and we have also 20 minus 17.5. So that's why we have 15 minus 17.5 squared plus 20 minus 17.5 squared all over, since every set there are only 2 data, or there are 2 values. So you have 2 minus 1. So we have negative 2.5 squared plus 2.5 squared all over 1. So 6.25 plus 6.25 over 1, all over 1, the result is 12.5. And that is the variance of the first set, 12.5. Let's proceed to the second set. So we will, the values are 15 and 30. Then the sample mean of 22.5. So that's why we have 15 minus 22.5 squared plus 30 minus 22.5 squared all over 2 minus 1. So simplify. We have negative 7.5 squared plus 7.5 squared all over 1. So the result, if we simplify this, okay, 56.25 plus 56.25 all over 1, and it obtained 112.5 as the variance of the second set. So 112.5. Okay, now you can stop this video, then you try to answer the third set until the last set. Okay, let us now reveal the variance of the third to the last set. So the third, 50, fourth, 12.5, fifth, we have 50, sixth, we have 112.5, seventh, we have 50, eighth, we have 312.5, ninth, we have 200, and 10th, we have 12.5. So these are the sample variance of the given sample values. Now, let us now proceed to the standard deviation. So if you already have the variance, it is easier for us to find the standard deviation of the given, sample values. You only need is to use this formula. So you only need is to get the square root of the variance. So for example, the first set, since in the first set, the variance is 12.5, okay, therefore the square root of 12.5 is 3.54. Therefore, the standard deviation of the first set is 3.54. Let us now proceed to the second set. So in the second set, the variance is 112.5. Then get the square root of 112.5. The result is 10.61, and that is the standard deviation of the second set of sample values. Now, you can do the third and the last. So just pause this video, then try to complete the standard deviation of the given sample values from the third to the last, okay, sample values, or the last set. Okay, let us reveal the standard deviation from the third set to the last set. 7.07 for the third, fourth 3.54, then fifth 7.07, sixth 10.61, seventh 7.07, then we have 8th 17.68, ninth 14.14, and the last set is 3.54.